Chapter 8, Section 5 is entitled Congruent Polygons. Now, when we're talking about congruent polygons, we're talking about any sided shape. So 3 or more sides of the triangle or not. We can talk about all the different shapes we want. But primary focus, especially when you get to geometry, you'll spend a lot of time talking about congruent triangles. You could easily spend a semester just talking about how 2 triangles are congruent. So that's where our primary focus will be today. You will spend some time on other things today, but not nearly as much. All right, so let's start over there where we're talking about identifying congruent triangles. Now, when we're talking about identifying congruent triangles can be proved a few different ways. Let's go through that. All right, the first one we can prove, we can say that 2 triangles are congruent if 3 consecutive sides in 2 different triangles are congruent. 2 triangles are congruent if 3 consecutive sides in 2 different triangles are congruent. Oftentimes we'll refer to that theorem or postulate as side, 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 or SSS. 2 triangles are congruent by SSS, means their sides all match up. So if I'm looking at those 2 triangles up there, in order to prove side, 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 you can see those triangles look very similar already. Right? I have to prove that one side matches up with another side, a second side matches up with another side, and a third side matches up with another side. That's all you've got to do to prove side, side, side. Side, side, side is usually one of the easier ones to prove because they're going to tell you that this side measures this, and this side measures this, and this side is this, and this side is that, and boom, you're done. Right? It's not always the one we get most frequently, but it's probably the one that's easiest to prove. Okay, next one. 2 triangles are congruent if 2 sides and the angle formed by those sides in 2 different triangles are congruent. 2 triangles are congruent if 2 sides and the angle formed by those sides in 2 different triangles are congruent. We call that postulate SAS, or side angle side. So to prove side angle side, you've got to match up one set of sides. So let's just pick this side and this side. You've got to match up another set of sides. So I'm going to pick this side and this side. But then you're only restricted to one angle because it's got to be the angle formed by those sides. I can't just say, okay, well this angle matches up with that, and I got 2 sides in angle. No, it has to be the angle formed by those sides. So these 2 sides make that angle. So I've then got to prove that that angle is the same as that angle. And if I can prove that, then I can say that those 2 triangles are exactly the same. All right, and the last one there. 2 triangles are congruent if the 2 angles and the side in between those angles in 2 different triangles are congruent. Two triangles are congruent if 2 angles and the side in between those angles in 2 different triangles are congruent. That postulate is known as ASA, or angle side angle. Note, obviously, there is no angle side side postulate. Think of the lettering and you'll figure out why. Alright, so to prove angle side angle, let's say I prove that this angle is the same as this angle. And then I prove that this angle is the same as that angle. I have to prove that the side between those angles then is also congruent. Well, the side that's between those two angles is this one here. This one is not, this one is not. I got to prove that is the same as that, and that proves angle side angle. There are other lettering combinations that work for other things. There's a topic called similar triangles. I don't know if we study or not, but it works with other lettering combinations. For instance, we can prove angle, angle, side, and then we can prove that two triangles are similar. Not the same, but just similar. Right? But for congruent, you restrict it to side, 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 side angle, side, and angle, side, angle. Now, when we're proving triangles are congruent, there's a lot of different ways to prove that those triangles are the same. All right? So you might see that I could prove two triangles are congruent by a couple different ways. That could happen. Right? So don't get into a problem and say, okay, it can only be side, side, side. No. It could be somebody might see side, side, side. Somebody might see side, angle, side. It can happen. All right, so let's go through the examples here where we're going to prove some triangles are congruent. We could write a two-column proof, which is, again, something you'll really do in geometry, but we won't do it here. I used to, but it's just not worth it. Okay. Take a look at example 1. It says that ABCD is a rectangle, and they want to know how ABC and CDA are congruent. ABCD is a rectangle. They want to know how A, B, C, and C, D, A are congruent. Okay, so let's take a look. First thing we know, it's a rectangle. So that gives us a lot of information just on that alone. Right? I'm trying to prove that this triangle here is the same as this triangle here. Well, that shouldn't be too bad because we already know that this side matches up with that side because it's a rectangle, opposite sides are the same. And we know that this side is the same as that side. So I've already got two S's in the thing. So I either want to try and prove side, angle, side, or side, side, side. Now, side, 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 unless you remember the stuff about diagonals of a rectangle, isn't going to be a lot of fun. There's an easier way to get there. What do we know about the angles in a rectangle? What do we know about the angles of rectangles?